In 7.2, we are adding and subtracting fractions. So we need to add them or subtract them. So these two are very similar. So whenever we do adding and subtracting, they follow by the same rule. It means that both of them must have something called a common denominator. They must have the same denominator. So you need to change them accordingly, whether you make it bigger or make it smaller. Like we did earlier on about simplification, to get equivalent fractions is by dividing the top and the bottom. We also did the same thing by multiplying them to check. So when we multiply them, we also must multiply by the same number for the top and the bottom. So what we use here is, this is the part where you actually use your LCM, which is your lowest common multiple. So if you want to use your lowest common multiple, it's fine. But after practice, or after a few practice, or after practicing for quite some time, you will actually get to see what number to change it to. So normally I will suggest you'll do it in a more practical way. It means that whichever way that you find it more convenient, you do it that way first, and then eventually you start to change a little bit. Okay, if you're completely new to this and you don't know what to do, well, the simplest way is you just change. Okay, we follow the steps first. So it stays here, add the whole number parts, means that if they're whole numbers or if it's mixed numbers, then we just remove the mixed numbers and add them together. We only deal with the fractional parts, which are the fractions that are that we want to see how we can add them together. Okay, same thing for subtracting as well, but subtracting is a little bit more complicated because sometimes you need to borrow. So for both cases, right, I personally will do differently for subtraction. I'll show it to you later. But here, let's just look at what we can do with question A. So we're just going to change this into common denominator. So let's look at work example A. We have 4 over 7, and then we have 3 over 4. So this one seems to be a little bit of a problem because the denominators are not the same. This and this, they are not the same. So if they're not the same, I cannot proceed. Cannot proceed if the denominators are the same. Aren't the same, sorry. So now because 7 and 4, they are not the same, I need to change it so that they are the same by multiplying. Okay, I cannot make it any smaller, so I have to just multiply. So these two, there's nothing much that we can do about it because there's a number 7 here. Both of them are rather small, and one of it is a prime number. So what I can suggest is you multiply according to this number. So the left-hand side multiply according to the second fractions denominator, times 4 times 4. Whereas the other side, we do the opposite. Multiply by 7, multiply by 7. Well, this is not cross-multiplying, by the way. If you think that, oh yeah, this is cross-multiplying, no, this is not. This is just changing them to be equivalent fraction. It means that I'm going to inflate, I'm going to make both bigger so that they have the same denominator. Okay, so now I multiply already. The first one I'll get 16 over 28. The second one I'll get 21 over 28. So when this happens, the denominators are the same. If you don't like to write this line, you can immediately go here. 16 plus 21 over 28. They are the same thing. Okay, because the denominator are the same, I can just join them together. Okay, so this is the same grouping, then we just do it and continue. We get 37 over 28. Then here we just a simple one to change it into mixed number. So your question is, how many 28s are there in the numerator? Answer is only 1. So 28 plus 9 is equals to 37. So it's 1, 9 over 28. Okay, I cannot simplify it anymore. So you can just leave it like that. Okay. Okay, so once we proceeded like that already, then if we can simplify, then we simplify it here. There's nothing to simplify in the whole number, so we don't need to do anything with the whole number. Okay, so let's look at the second one. This is A1, this is A2. All right, so let's look at what we can do here. It says 1 over 4 plus 2 5 over 6. Okay, so if it's addition, I'll just let it be, okay? I'll just follow exactly what the book asked me to do. I just add the whole number together. I'll get 3, okay? 2 plus 1, I'll get 3. And then I'll just do the other one on their own. Okay, so now I'll do the fraction 1 over 4 plus 5 over 6. So I just do it separately here. Okay, this is the one that I wanted to let you guys know. When we have things like this, we need to make sure that we can change it according to what is the easiest way. We can do the same thing like just now, where we do multiply by 6 and then multiply by 4. We can do that. Let me just show you what happens. So here I multiply by 6, multiply by 6. Here I multiply by 4, multiply by 4. Then I will get 6 over 24 plus 20 over 24. And I can get 26 over 24. Then I can get 1, 2 over 24. Then I just add it here. Add the whole number together, I get 4, 2 over 24. I can simplify and become 4, 1 over 12. Okay, if I don't want to do this, okay, this way it seems to be what I would say overinflating. The number gets too big. Let's try to find what multiples do they have that are in common, 1 over 4 and 5 over 6. What common multiples do they have, 4 and 6? So in my head, it will probably look like this: 4 times 1, 4, 8, 12, 16, 20. Then the other one is 6, 12. Oh, we got 1 already. So here it is. Once we get it, then we're done. We're good to go. So now my goal is trying to change it to 12. Because 12 is definitely a smaller number as compared to 24. So that will help me simplify my work. So 4 times 3 becomes 12, 1 times 3 then, because bottom times 3, top must times 3. The other side, times 2, then I can get my answer. Again, the same thing, 3 over 12 plus 10 over 12. 13 over 12, 1 over 12. Then I can repeat the same thing about putting it up. It's the same thing. So this way, I don't need to take another step to simplify it, because I made it bigger and then I have to simplify it to make it smaller. So this is slightly easier, but it takes a little bit of practice where students get to do things faster, get to do your work faster in this particular manner. So there's like always beginner stage, and then this, like I would say, like advanced stage. All right, let's look at number 3. Okay, for number 3, right, I prefer to do it this way every single time when there's a subtraction. Every time there's a subtraction, I will not hesitate to just change everything to mixed number. I'll change everything to improper fractions. Immediately, I'll change all of it. So the first one, I'll change it to 19 over 3. The second one, I'll change it to 22 over 9. Okay, I won't do anything else because to me, this is more important. Okay, as you can see, one number bigger, one number smaller, it doesn't really matter. I cannot do anything because this one here, they are not the same. I still need to change them to be the same. So I cannot say, oh, 19 smaller than 22. No, it is not. Now I need to change 3 into 9. How do I change 3 into 9? By multiplying 3 here. Okay, if you want to do the one that we did earlier, times 9 times 9, times 3, 10. But you get like extremely big number. So try your best to minimize the work that you have to do. So you have to do it very smartly. Okay. So now times 3, I can just change it to 9. Then the other side, I just don't do anything. So 22 over 9 stays as it is. And the other one here is 57 over 9. I can solve it here immediately. 35 over 9, and then I can just simplify it. 3, 27, 8 over 9. That's it. This is how I would prefer to do it. Because some people like to borrow from the mixed number. I find that a bit redundant because it overcomplicates things. So normally, okay, let's try to progress from here just to, so that you can see what I mean. So 6, 1 over 3 minus 2, 4 over 9. So let's say I minus the denominator, I minus the whole number away, so I get 4. So I got 1 over 3 minus 4 over 9. So let's try to change it. I get 3 over 9 minus 4 over 9. It's impossible. I cannot do anything here. Okay, I get a negative. That overcomplicates a lot of things. Okay, if I don't even if I don't do this, I say, oh, okay, let me just change them to be the same denominator. 6, 3 over 9 minus 2, 4 over 9. Okay, because I times 3 times 3. When I do this, it's still not enough. Then some workbook or some course book, they will teach you to say that, oh, you're going to borrow 1 from the whole number. So it looks like this. 5, 12 over 9 minus 2, 4 over 9. To me, it's just overcomplicating things. Okay, it is doable. I'm not saying it's wrong. It's just that it's rather complicated. So 5 minus 2 is 3, 12 minus 4 is 8 over 9. If your concept is there, whichever way is fine, honestly speaking. But I find this way the easiest way. To just change it to a mixed number. Even if you want to overinflate it, you want times 9 here, times 9 here, times 3 here, times 3, it can because you have a calculator. Okay, why you cannot just type this in your calculator and get the answer? Well, you can. Unfortunately, in your exams, they will say, work this out without a calculator, but you have a calculator at hand. You can type the answer, type the question to get the answer immediately. But the goal of the examination is to test you if you can write the working and slowly show the examiner what you're trying to do. Okay, this is your working. Don't get me wrong. Don't say that, oh, I don't want to write that because I don't know whether it's appropriate or not. Well, these are your working. You need to show. But when you write it smaller. Write smaller than the actual number. So you can see the big number here. There's a small number here. All right, that is your little ones are your working. Okay, so once you are familiar with this, then you should be able to do the exercise below. We look at the last one here. Dakarai said that we should use a counter example to show that he's wrong. If I add together 2 different fractions, my answer will always be greater than 1. Well, not necessarily. 2 different fractions, I can use 1 over 10 plus 1 over 9. Definitely not greater than 1. So why? I change it and I show it to you. Times 9 times 9 times 10 times 10. I get 9 plus 10 over 90 is 19 over 90. Less than 1. So this is how you want to use a counter example. You don't need to write a long sentence, just show. If I take this 1 over 10 plus 1 over 9, I will not get greater than 1. Okay? It doesn't happen all the time. Don't forget to like and subscribe.